This section is about how far we can see and how we can calculate that distance. Imagine the ground is flat with no hills or buildings in the way, and we look as far as we can to see where the ground meets the sky. A good place to get an unobstructed view like this is by looking out to sea. The meeting point where the ocean meets the sky is called the horizon. It happens because we live on the Earth, a ball, and the ground slopes gradually away from us, eventually meaning that we can't see it anymore. We can calculate this distance relatively easy using Pythagoras' theorem for a right-angled triangle. When we put the numbers in, we find that the distance to the horizon is about 4.5 kilometres on the Earth. On the Moon, the distance to the horizon is only 2.3 kilometres. Because it has a smaller radius, it curves away more steeply. However, Jupiter, the largest planet in the solar system, has a radius of over 10 times larger than the Earth's, and if we could stand on it, we'd find that the distance to its horizon was 15 kilometres. What makes a much bigger difference to the horizon than the size of the planet is your height above it. If you're an ant, your horizon would only be about 10 metres away. But if you were on top of the highest mountain in the world, you'd be able to see 340 kilometres. Now we've got a way to measure distance to faraway things without walking it. Go up a hill to the height at which the faraway object, for example a river, is just visible. If we know how high up we are, we can calculate the distance to the horizon and therefore the river. Are there other ways of calculating distances without measuring them? For example, how do we know how far away the stars are? We can calculate these distances using something called parallax. Parallax is about relative movement. Look at objects from two different viewpoints, and near objects appear to move more than far ones. You can do this easily yourself. Hold a pen near to you about 20 centimetres in front of your face and have a cup directly behind it on the table about 50 centimetres away from you. Close your left eye and look at the pen through your right eye. The pen moves to the left of the cup. Now close your right eye and look at the pen through your left eye. The pen moves to the right of the cup. So how do we use this apparent movement to calculate distances? We use trigonometry. If we can measure the change in angle between the near object and the far object when viewed from two locations, then we can measure the distance to the near object. We can use this method to measure the distance to the Moon, the planets, and the near stars. For example, if a star had a parallax of 1 arcsecond, that's 1/360th of a degree, a tiny angle, it would be 3.3 light years away. Trigonometry allows us to calculate the distance to a faraway thing without having to actually travel to the faraway thing.